Oh, hello there. I'm assuming you're watching this video because you want to know more about quantum computers. Well then, you're in the right place. Let's go. What are quantum computers? How do they work? And what does it have to do with all this nonsense behind me? So our computers today use transistors, like one I'm holding right here, but way smaller in size. These transistors act like switches which turn on or off, like normal switches. So let me show you how this works. Imagine an electrical pulse or current coming through this way, enters this terminal right here, and when it comes to the center, we can either allow or prevent that pulse or current from coming through to the other side. So basically, this current is read by the computer as data, which is then represented as either 1 or a 0, which we call a bit. And combination of these bits, or ones and zeros as you can see here, help the computer execute tasks. The more combinations we use, the more complicated tasks we can execute. This is hugely simplified, but for easy understanding, the more transistors we have in our computer or our phone, the better it can process data. For instance, the iPhone that I'm using to record this video right now has about 8.5 billion transistors to help it run all the apps and even the camera that I'm using right now. But when it comes to certain problems with certain levels of complexity and scale, these computers are ill-suited for the job. Let's say we have a maze where the goal is to get from one side to the other. A classical computer would have to go through each individual route and determine the correct path to the opposite side. Well, this method of trial and error is very time consuming, especially when we're dealing with bigger problems. For instance, a bigger maze where there are like hundreds of possible routes. That's where quantum computers come in. Quantum computers use quantum bits or qubits instead of bits. These qubits can be either a 1 or a 0 or both of them at once. But when we finally test or observe it, then it finally decides whether it wants to be 1 or a 0. So let's go back to our maze problem earlier. Quantum computers, unlike normal computers, don't have to go through all the paths one by one, but instead, using superposition, they can assess all paths at once. And using clever algorithms, we can determine which is the likeliest path for us to reach the other side. Just like classical computers where we add bits, in quantum computers we add more qubits. So for each qubit added, the possible values that can be stored in each qubit increases exponentially. So 1 qubit can store 2 possible values, 2 qubits can store 4, and 20 qubits can store over 1,000,000 possible values. One potential use of quantum computers is for database searching. For instance, we want to find nickname for Hamilton in this database. A normal computer would take a long time to go through each one of the entries to decide, while a quantum computer can do that in about square root of the time. Another potential use for quantum computers is to carry out simulations that would otherwise, when run by normal computers, would be either very exhausting on resources or even sometimes inaccurate. So these simulations can benefit researchers and scientists in physics, chemistry, and even medicine. But of course, there are huge challenges to be surmounted. One of them is to reduce costs. Companies like Google and IBM use superconducting methods to manufacture their quantum chips and quantum bits. So they use this super fridge to cool down their quantum chips and qubits to absolute zero temperature. These quantum bits and quantum chips are highly sensitive to temperature and even dust particles. So by using this method, they can ensure that the quantum chips don't get contaminated, or else the whole machine will malfunction. And the costs for maintenance of these factories and machines usually take up to hundreds of millions of dollars. And if we want to produce these quantum computers at a large scale, new breakthroughs and innovation would have to surface. And again, billions of dollars would have to be consumed I think a conclusion that we can agree with is that quantum computers will not replace our current computers because they are more economically sound and easier to use for all of us. But it is highly possible that in the next decade or two, we can see quantum computers being used in highly specialized fields to make breakthroughs and new discoveries possible.